Probability theory is rarely an exact prediction of the future. However, when used properly with a good understanding of its limitations, it can be a very powerful tool for the interpretation of statistical information. In some cases, predicting the future probability of an event can't be determined using common sense. In many business and scientific applications, you have to use formulas and other problem-solving tools. For example, sometimes determining the total number of possible outcomes can be confusing. This is often the case when you have combined events, two or more events which can occur simultaneously. A simple example would be the tossing of 2 coins or 2 dice. If you toss 2 coins, what are the possible outcomes? Let's see. You can get 2 heads, 2 tails, or 1 head and 1 tail. So at first it looks like 3 possible outcomes, so the probability of getting any of these outcomes would be 1 out of 3. But if you try tossing 2 coins as an experiment, I'll bet you'll find the chance of getting 1 head and 1 tail is better than 1 out of 3. In fact, there are really 4 possible outcomes in this example. To figure it out, you have to look at the possible outcomes for each coin in the form of a table. Each one is acting separately, so the probability of which way the coin will land must be figured separately. Therefore, the probability of getting 1 head and 1 tail is actually 2 out of 4. An alternative to using tables is a tool called a tree diagram. This tree diagram shows the number of possible outcomes for tossing 2 coins. Coin A and coin B can both turn up heads or tails. What about something a little more complicated? Say rolling 2 dice and having one of them end up showing a 5. To figure out the probability of this